I'm very happy to be here. I'm sort of very honored to be one of the last sessions at the conference. I appreciate all of you being here, coming to this session. We're going to talk about tests. We're going to talk about integration tests, about how you can make it very, very simple. And hopefully, this is going to be, well, it is going to be like a demo-heavy session. And we're gonna see how it feels. How many of you know and use test containers? Approximately half. How many of you don't know test containers? Approximately half. It's very good. We're gonna start from the sort of more basics, and then eventually gonna go there. So, my name is Oleg. I work for a company called Atomic Jar, which is the company, a startup created by the maintainers of test containers libraries, and we would love more developers to have easier time writing better tests. Because, well, my personal point of view on that is I'd love to live in a better world, and there are many things wrong with the world, and not everything we can fix, but hopefully we can fix and we can make the developers write better software. Because as a community, one thing that we know is if you have better tests, you can have better software. So this is what we are trying to achieve. If you have questions, please shout at me during the session in the middle. If you don't understand something or if you have an interesting take, I think it's much easier to do that than to wait until the end of the session where you will forget the question and then it's going to be awkward. So please interrupt me if you have a question. And if you don't have a chance to ask your questions, but you really want to chat about test containers or software development in general, like I'm over 30 years old, so I'm old and wise. I feel I can give you advice about life in general, not just software engineering. So I'd be happy to connect with you online and talk about anything like that. So, tests. When we talk about tests, very often, this is the picture that developers have in mind. For a number of years, we thought about how we can organize our tests, and the idea was that, okay, there are different types of tests, and we should approach them differently. Some of them we're going to call unit tests, and they're going to be verifying the behavior of individual components of our application. And they're going to be small, they're going to be easy to write, they're going to be easy to understand and maintain, and we're going to have a lot of them. We're going to cover all our code with unit tests, and it's going to be great. And then on top of them, we're going to have a little bit more complex, maybe in the setup, integration tests, which will verify the behavior of our application with multiple components, like at once. And then for a number of years, they were complex to maintain and not very liked by developers because they were like flaky and then they will fail for no reasons. And then at the very top of the pyramid, we would have the end-to-end tests, which would run in the environments similar to production, right? With the whole components that we need up in there, our applications deployed into that. And then because of the complexity and the how resource intensive those are, there will be even like fewer of those. So we'll have the pyramid. And then lately, the development, how we write software has been changing. And so many teams individually discover that they would like to change this status quo of how they structure their test suites. And the main thing there is that the importance of integration tests is getting higher and higher. So specifically in the setups where we have microservices or some sort of deployments where a lot of like logic of what the application is doing is tied to how it interacts with other services, maybe going through the message brokers, maybe sending some data to the database, maybe, I don't know, storing some data to the database and then pulling the messages from your message broker in return. So the actual business logic, the implementation details of your application will be smaller. So it would not make so much sense to cover everything with the unit tests because the application never works in isolation because, well, it's a small part of a giant fleet of microservices. So the unit tests will become less important and the integration tests will come forward and you can build your test suites and rely on your integration tests. And there are a number of advantages. They're high-level tests. The technology is there to make it easy to write and trivial to run, like in your CI environment, locally, in a consistent manner. I can run my tests, integration tests. You can run your integration tests on the same, like on any machine. So the technology is there. And then, so this honeycomb structure is from a blog post by Spotify about how they test their microservices. And then how they say, yeah, they still have some unit tests. They still have some integrated tests, which is sort of run in the production-like environment, in the staging environment, if you will. But the biggest chunk, what they actually rely on to automatically figure out whether a certain commit is good to go into production or not, those are the integration tests. And the benefit of that is that if you can run those locally on your machine sort of becomes the staging environment, because you can verify all the failures locally. And then if it passes locally, that means it will most probably pass in the same consistent manner in CI. And then you can automatically continuously deploy that into production and then figure out from there. So how do you do integration tests? It's a good question. And there are a number of approaches. And historically, sort of, we went from more kind of rigid, structured approaches to more flexible and more beneficial and useful for the integration testing. So sometimes you can have the shared instances that your platform development team provides in your CI environment, or you can have a local installation of your database running on your machine, which is where you installed Kafka 2 years ago, and since then you're using the same version of Kafka because you never managed to upgrade it. Or sometimes you could use the in-memory solutions, which are never actually quite fully compatible with the versions of the applications that you need to run in production. Or you rely on the sort of Docker Compose-based setups, especially lately, which works great because you can define the environment that you need for your integration tests. But at the same time, it doesn't work very conveniently because that setup is fixed once you have your Docker Compose file, because you can run your services and then you can stop them, and you cannot do much more than that. And your tests actually are a very interesting use case because you would like to test your application in different scenarios, under different conditions. What happens when my database schema is broken? What happens if I overwhelm my Kafka with too many messages on topics? Or can my application survive if the database is not available for 10 seconds? Sometimes your tests need to break the environment they run in. So if you have a single version of the environment, it's just impossible because, well, the consequent test cannot run. So you want to have a flexible environment where the tests themselves declare what they need for running and provide the configuration. And this is exactly what you can get if you only had the programmatic API to this environment creation. How amazing it would be if your, say, tests could have a programmatic way to construct the environment. For example, with a JUnit rule. So every test can say, I want the database here. Give me Kafka. Please create me a MongoDB instance. And automatically tie that to the life cycle of your tests. And there was this, 7 years ago, there was this gist by Moshe, which I think he's from Israel, so it's very fitting. And yay, go Moshe. Very good. And very much until recently, I didn't know that this was the inspiration for the actual test containers. But imagine such a situation exists. What does this rule, what does this integration need to accomplish? It needs to do 3 things. It needs to figure out how to do the container creation and life cycle. So you need to start and stop the containers. You need to configure the containers, like what they expose, what files need to go in. So you need the API to manage the configuration, both of the container and the service within the container, right? So like you need a way to provide maybe a database schema, or say that Kafka, I just don't want a Kafka, I want a Kafka with certain topics. Or if you run, I don't know, something else, give me a technology. If you run local stack, you test against your applications that need to run in AWS. and you want to test it locally, you will run local stack in the Docker container, and you say that I want local stack with DynamoDB, S3, and Lambda available, right? You need somehow to configure services in the containers. So you need that API. And then sort of what would be really, really great if that thing integrates not just with Docker, but also with your test or application frameworks, such as Spring, for example. How many of you use Spring? Very good. How many of you use something else? A few. Very good. And the Moshe friends. Which is, maybe that's the next big thing. Nobody knows, because you can see. So it would be great for this to integrate with Spring, for example, to conveniently configure your applications to use those services. Which is, ta-da, a few years later, the situation was that this GIST and this approach was superseded by the Testcontainers libraries, which this GIST was actually the inspiration for. So Testcontainers. What is Testcontainers? It's a collection of libraries that simplifies your testing by integrating with Docker and giving you the ability to run anything that runs in a Docker as a part of your integration test or just any test. It's an open source project. They're available in different languages. The Java implementation of that is the oldest, which is, I think, 7, maybe 8 years now, which if you are in the Java community and you don't feel like this is a lot of years, because you remember Java like 1.2 something or pre. How many of you have seen Java without generics? A little bit. Okay. I joined after Java 1.5, so never had the privilege. But it doesn't feel like a lot of years, but in terms of in Docker years, that's a lot, right? Because Docker was just a year older than the project. So very soon after people realized how convenient and nice Docker is for running isolated processes, somebody was like, oh, we need to create a library to use that programmatically. Testcontainers uses the Docker Java API library. So we don't require you to run actually to have any particular Docker implementation or the command line. It just goes directly and sends the commands to the daemon. So you can use it with any Docker API compatible implementation. So that could be your local Docker desktop if you run that, or any other Docker solution, Rancher desktop, Kalima, maybe a remote Docker host. We internally are building like a cloud service for running the containers, and you can use that with any Docker implementation. And then it integrates actually with the frameworks. A lot of them provide the integration out of the box. Somewhere you need to add the dependencies. And if you're not using any frameworks, you can just, you can add a dependency, you add a library to your project, and suddenly you can say, like, please give me Kafka. Thank you. Right? And it works not just with the certain services, right? It can run anything that you run in a Docker container. For example, headless browsers, if you want to use like UI tests or your Playwright scripts or your custom services and so on. So it's pretty universally great and works really, really well, which is great. And it's also not just Java. So if you come from companies where there are other developers and they're not using Java, but some other languages, Testcontainers approach, it's not something that API specific, right? So there are implementations in other languages that implement the same idea. There was a community driven, so people were like, oh, I wish something like Testcontainers would exist in Go. And then they would go and create Testcontainers Go, and Testcontainers.NET, and Testcontainers Node.js, and Testcontainers Python, and so on. So you can come back to your teams and say like, oh, I know that you're writing Go, but maybe you should write better tests if it's applicable. So this is great. And the other great thing is that there is a growing ecosystem of modules that are giving you abstractions out of the box to run certain technologies. Because you might not know how to run a certain thing in the Docker container because it might require some configuration, some environment variables, some particular port exposing certain ports, and so on. But what you can do, definitely, you can say, like, here's my dependency to run my Kafka in a Docker. How many of you know how to run Kafka in a Docker container? 4 people, 7 people. Very good. Not many. I don't, but I know that there is a library, and I can just say Kafka container, boom, and I have it. So the ecosystem support is great, and this is a great place to collaborate with the community that uses those technologies and provide maybe some test-specific optimizations if that is applicable. Because in your tests, you not always need to have the same default settings as you use for the production environment. And you can maybe speed up your test execution for a little bit just by using a different default config. So modules are existing. It's all universally great. And it's just that me saying that is great. You could be like, oh, like, of course you're saying that it's great because you work for them. But it's also other people. So recently, earlier this year, the technology radar by ThoughtWorks put test containers into the adopt category. And they said it very nice things about this being a default option for creating environments for their tests, which reasonably means what it means. It means that you have to really understand what you're doing and why you have a reason not to use test containers. So that was very nice of them. And then it's also included by default in various frameworks. For example, for Spring, which most of you are using here, this is the default dependencies that you go to start.spring.io. You type test into dependencies. That's the first thing that pops up. Might be alphabetical search, but it is definitely out there, and the integration is very, very swift. So without further ado, let's talk and let's look how it feels and what it means to write tests. And I will have a few demos that I want to run. So I'm going to go into my IDE, and we're going to cover a very basic scenarios first: how to create a container, how to tie it lifecycle to your unit tests lifecycle, and then how to expose the basic configuration for the Docker container. Let's do that. Let's do that. Let's see if it works. So here's my, not this one. Where's the other one? No, this one. Let's see. So this is my very first test. And this is my very first, this is a normal project. It's a normal project. It's a unit test. I can run this. My IDE is there. What I'm doing here, this is the definition that we want to see. The basic abstraction that Testcontainers has is generic container. What it takes the name of the Docker image, and you can put it anything there, and it will automatically kind of sort of go and when you run the test, it's going to go and pull that image. Go away. It will automatically go and pull that image. Where's my window? It will automatically go and pull that image. Idea, you are embarrassing me in front of people. So, and then it will give you the object that you can work with, right? So you can provide the configuration for that object. For example, this is the web application, HTTP bin. And it needs to be accessed through the intranet. So we're going to expose the port 80 from the container. And then you can use that container in your class. So here we're going to do the following. We tie the lifecycle of the container to the JUnit using a Testcontainers JUnit extension and the annotations. We're going to highlight the class and annotate that with Testcontainers. And then that means that all the fields marked as container will be started in according to the JUnit lifecycle. If the field is static, they're going to be started once per class, sort of like before all and then stopped after all. If the field is instance field, it's going to be started and stopped before each and stopped after each. So you can control whether you want like one container per class or one container per test, and I can run this. So here, what we're going to do, we're going to start the container, and in this test, we're going to access it on the port 80 in the local host, and we're going to just send the request, and we assert that the status is OK. Do you think it will work? How many of you think it will work? How many of you think it will fail? OK, most of you think it will fail. Of course it will fail. But the reason why it is failing is not just because something is wrong with my Docker setup or anything. My Docker's environment is fine. We are connecting to Docker, and we are running the checks, and we're verifying that the Docker version is correct. So Testcontainers takes a lot of effort to make sure that if something is wrong with your environment, we fail early. Because it's the worst thing in the world to run your tests, see that it failed, and then debug it for 2 days, and then realize that your Docker was out of date or you didn't have enough space on your disk to create the containers. So we run the checks to verify the Docker environment is fine. After everything is passed, we also do extensive cleanup in all cases. But why it fails here is because there is nothing available at port 80. There is nothing there. And why there is nothing there is that despite the fact that we're exposing port 80 from within the container, it is mapped to the high-level port on our host machine. Why we do that? Because that's the best practice for integration tests. Because there will be no conflicts when you run a couple of services that need to exit the same port, right? If I want to run a cluster of my Postgres databases and they need to run on the 5432, which is the default Postgres port, right? From within the containers, they will get the hosts outside on that port, but on the outside, on your host machine, there will be random high-value ports, because then you can run multiple things, or you can run your tests in parallel, if you will. So how you can kind of sort of fix that issue? Very simple. You use that container object to ask, where is it running, right? And this is how you can provide the integration. So here we can run this test, and it will run very, very swiftly, and then it will pass. Because now we're accessing this definition on the particular thing. And you can see here, let me just verify here, right? So this is my Docker. This is my Docker, and there are no containers running. So the test passed, and the containers went away. And we do this cleanup always. If it's like, if the test passes, we clean up the containers. If the test fails, we clean up the containers. You run your containers in a remote Docker host, right, on a different machine, and your laptop bursts in flames, internet goes down, everything is broken, we still clean up the containers because we want your test to be repeatable. And next time you run the test, we're going to have a different set of containers. So you will never connect to a Kafka instance that you started 2 weeks ago and forgot about that. And your tests are failing, and you need to spend a week debugging that. So the cleanup is very, very, very good. So, and that's how you run the tests. And you can just do other cool things like that. So it's not just, for example, running the predefined containers. We can, for example, build the containers from the Docker files if you want. We can specify some environment variables. We can specify the configuration, what it means, what it needs to be exposed, copy files into the containers, copy files from the containers. We can specify what it means for the container to be ready, which is very important because you run a database. Imagine you run a database and the container is actually started, but the database is not ready to accept your queries. You don't want to have any timeouts or anything like that, right? We want to make sure that when we return the control flow to the tests, the setup is ready. So you can specify custom wait strategies, what it means for the containers to be ready, and then you can run all those things, which is pretty universal great. And this is how you do, and this is the basic integration, and of course this test will pass. This is not the most interesting setup. The interesting things start when you actually start testing your application in conjunction with the containers. So it's not just like, oh, has my database started in the container? But like, actually, can your application do something with those containers? And the answer to that is true. So, okay, this passes. Very nice. So I have here a Spring application. It's a very simple Spring application. What it does, it doesn't do a lot, but it binds on the ports, and it uses Kafka to enable the communication between two classes in the same application. It uses a Redis to store some data in the Redis, and it accesses that using Redis template. And it also uses the normal relational database to store some other data. So it's a little bit maybe over-engineered example, but what it needs three things to run. It needs Redis, Kafka, and the database. And without those, I cannot run this application. So here's my test suite, and I have a diverse set of tests. I have a test that actually talks to the database and verifies that my context wires together and verifies that my sample data for the test exists. I have a test that tells me that my actuator responds with 200. I have my test that actually verifies the behavior of my application. So the sample application works by, it does like ratings for the conference sessions, right? So at some conferences you can say like, oh, this was a 5-star session. Oleg is the best, yay. So this is the sample application for that. So here what we're gonna do, we're gonna send the HTTP request to ratings, and then we're gonna wait until that data will propagate from the other side of our application, passing through Kafka, databases, and all those things. We're gonna use the library called Rest Assured here to have my like high-level functional integration tests. And we even have a force test here somewhere that tests the negative use cases, so which you should never underestimate. Right, so the test suite. Can I run this? I can run this. Look, it's abstract integration test. The parent class defines that we're going to just say this is a Spring Boot test. We're going to run our application, and we're going to configure our rest assured request specification to go into that local port. So there is no environment configuration. I'm going to run this, and then how many of you think this will pass? The test? Can they pass? No, they cannot. Oh my God. Right, of course they cannot, because there is no environment. So let's create the environment. And the simplest thing, so we have database, Redis, and Kafka. Which should we start with? No, we're going to start with the database. We're going to start with the database. And the simplest thing to include the database, JDBC database normal, into your test is a configuration property. Look, what I can do, I can say my Spring data source URL is where your normal JDBC URL goes. So what if I can do JDBC, and then I will add the test container suffix there. Then when Spring will go and try to find the driver for that JDBC URL, it will not find the normal driver, but it will find the test containers driver. And the test containers driver will take this URL and will be PostgreSQL, say we're going to run 14 Alpine version. And then it will say, oh, give me that container with that database, and then return the control to normal JDBC driver. So this is how you can introduce your JDBC-based database into the setup. So now with the database, I can verify that my application wires together and that my database actually has the data initialized in there. So our first test with the test container setup for the Spring application passes. So it wires together, and it works. The healthy test here will still not pass, because besides requiring a database for wiring up the whole thing, it also requires Redis. And it will tell you, it will just think about for a second and it will fail, because it will be like, oh, there is no Redis. And I really want my Redis because I want it to be up. And here Redis is down. So we need to create Redis. How do we create Redis? Exactly the same way as we did in the other things. We're going to say that this is a static generic container. There is no module for Redis, but it's fine. We're going to say a new generic container, and we're going to say Redis, and we're going to say this is 6. Was it 6? Was it 6? Yes, 6 Alpine. How cool is that? There's the content assist on the test containers API in strings, in JetBrains IntelliJ IDEA. So we're going to run Redis, and we're going to expose the ports 6379. So now our Redis is there. What else we need to do with this Redis? There are 2 more things that we need to do. We need to manage the lifecycle. We need to start this Redis. So currently we just defined that we want a container. We need to start this container, and then stopping will be automatic because test container stops it automatically, but we need to start it somehow. We can use the annotations to tie it to the lifecycle of the JUnit tests, but we don't have to. So, because here we can have all the methods that you want. You can configure everything on the container, override the command, override the environment, create the network, copy files in there. But I can also say, like, for example, start or stop. I will not do it here, because the other thing that I need to do, I need to make sure that my Spring application not just starts up, but it also knows where my Redis is running. So my application connects to Redis and works against that particular container. How do I do that? I will use the thing called dynamic property source thing. So I'm going to do public static void setup things, and I will give it a dynamic property registry thing. Now, this is the normal method. I will mark it with the dynamic property source annotation. And what it will do, it will run this method before my tests, and any configuration that will put here in this registry, it will override my static configuration that is available from my application properties, anything like that. So I can do registry, and I can say, add me the Spring Redis host, right? This is where my Redis is running. How do I get this? I just ask my Redis, get host, and the same thing happens with the port, right? Get first mapped port, because we mapped just one. right? And then when my application test will start, this configuration will overwrite whatever I have in my application properties, so I can dynamically create my environment for the tests. Of course, I need to start this thing somewhere, so I'm going to use the startables deep start Redis join. This is the convenience method. If I have more containers here, right, then it will start them in parallel, for example, right? So if I have 2 Redises or some other services. So now, I think now, I can just go and run this healthy test and make it green as well. Because now, I have my database thingy, right? My database is running because I have this integration. And my Redis is running because I have this integration. And it will obviously pass. So now we have the green test. This is very nice. I love seeing green tests. In the life of a developer, there are fewer, more like happier moments than seeing the tests green. Unfortunately, they're not very prolonged, because once you see the green test, you're like, okay, what's the next task? And the next task is, of course, to have the full tests that I have here, which will still be in error because there is no Kafka. So now I'll create the Kafka as well here. So I'm going to do the same thing. And Kafka is the thing where there is a module for that. Redis is just super simple because it's just one line. It doesn't make much sense to have a module for Redis. But for Kafka, there is. And how do I do that? So how do I create that? I add the dependency on Kafka. So there is org Testcontainers Kafka module that I can bring in. And then it will bring the classes to create my Kafka. And then I can have a bunch of them. Like I can have Red Panda, which is Kafka written in C++. I can have Postgres. I can have my K3s, which is the Kubernetes implementation. So I can run my test against the Kubernetes cluster if I will. Just say, like, give me a cluster, and then boom, there's a cluster. And I can deploy things or configure my Kubernetes client without any YAML, which is very great. It's a win in my book. Mongo, MariaDB, Cassandra, Elasticsearch, ToxicProxy. I know there is Couchbase in the expo. Let's do the Couchbase thing. Couchbase? Wasn't a part of the demo. I hope it works. There is a Couchbase module. If you're not sure, you can go to, for example, here, and you can say Couchbase, right? And there is Couchbase module, and you can see how the basic definitions, the dependencies that you need to add. Couchbase. Okay, very, very good. So it's supposed to be there. Nice, I have it. So now I can test my application with the Couchbase containers as well. So what I need now, right? I have my Kafka implementation here. So I can do Kafka container, and I can say Kafka. And I can do new Kafka container, and just Kafka container. And they just need to put the Docker image name there, which would be the Confluent Inc. CP Kafka. And then, for example, 546. I know this version works very nicely. And this is it. This is it. I need to start my Kafka, and I need to specify sort of the registry. How do I configure Kafka? Who knows? Spring, Kafka. It's called Bootstrap servers. Bootstrap servers. How do I get this URL where the Bootstrap servers is running? I ask my container where it is. Because it's not just the API that tells me, oh, to run Kafka, you need to run that container, and you need to specify those environment variables, and you also need to figure out what to do with Zookeeper. But it also gives me the sort of convenience API for the common tasks that I need to configure things. And this is the beauty. Because you have any sort of, you can build any layers of abstraction. It's very, very easy and nice. And you can just run this setup. And then somebody took care of this. And then somebody understood how to run Kafka in the container. That you need to start it, and then you need to run it. And then while it starts, after it started, you need to run a certain command, so it will advertise the listeners on the correct ports, and so on. As an application developer, you don't need to figure that out by yourself. You don't need to define that configuration in a YAML file somewhere, which is external to your tests, which will definitely kind of sort of disconnect from the actual test. You just say Kafka container, start, run. And I think with this, with Kafka ready, database ready, and the thing ready, we can run all our test suite. which is kind of cool. I think it will pass now, unless there are some typos in the strings, which is, I cannot do anything with being nervous on stage and making typos in strings. But we can run this and everything should be fine. You can see the ratings, test ratings passes. We run actually the HTTP queries against our application, and then it returns. It's very fast. The configuration is fully dynamic. I can check in that into my Git, right? Into my version control. And then you can check it out and you can run it, and you don't have to have anything, just a Docker environment available on your machine or like in your CI. And the test will run the same way. Oh, here, by the way, here, I don't even have my local Docker. So I run the Testcontainers cloud, which is the backend that we developed at Atomic Jar, which I wanted to, it would work with a local Docker as well, obviously, but it's easier to rely on the cloud a little bit. So here, let me just quickly show you that thing, right? So we went a little bit further with the demo, but if you want to check out Testcontainers cloud, we're currently in the private beta, so there is not like sort of the self-sign up, but what you can do, you can just join and go on that URL, fill a little form, and then I will see that you are here, and you can sort of will skip the line, and we can give you access to Testcontainers cloud. And then you don't need to run your containers locally, and it works very, very nicely. I would appreciate all the feedback. If you run your Testcontainers tests for that half who have the Testcontainers tests, please check it out. I'd appreciate that. Right, but you don't have to, of course. Any local Dockers, any Docker setup would work. Right, so we run with the demo a little bit further. This is what I wanted to show. And we looked at the modules, we looked at the Spring configuration, we looked how to start the containers manually. Oh, this is a good thing. I wanted to show you a thing. So we're gonna get to the chaos testing in a bit, which is, I have 2 more demos to show. One thing that I wanted to show is very, very cool, I think. So it's called the reuse mode, right? What I can say my tests, I want to reuse my Kafka. And then this will opt out my container out of the lifecycle management and automatic stopping the containers. It's not just the API. I also need to have my sort of here cut. I will make it larger in a sec. Grep enable. Oh, reuse maybe. Right? So my environment needs to consent to run the containers longer than the tests. But after that, what I can see is that my containers after the test are supposed to be reused. So let's see whether it worked or not. Where's my Kafka? Oh, I must, what? Oh, it's false. I need it true. Okay. No. Wait, let's do this. It's supposed to be true. Wait. Testcontainers. I'm going to show it to you. Right? So we're going to go there and we're going to do A and we're going to do true. True. Right? And we're going to save it. Right? And then we're going to run this test. And then it's going to preserve my Kafka from running there. Which is fine. Right? And then next time I start my test, my Kafka doesn't need to start, which is great. So it can speed up my, especially like local development cycle while I develop my applications. It can speed up very, very much. Of course, it's a trade-off, right? Of course, it's a trade-off because it sacrifices isolation of your tests for convenience and performance of the startup. So you need to make sure that you want that particular thing. But here, for example, now Kafka, where's my Kafka? Kafka. Here. Kafka. Right? Oh my God. Something is broken. So Kafka was supposed to be starting properly, but something is not right. I don't know. I didn't save the file maybe. Right. Let's keep it. You need to understand what is there with the reuse, and then it happens. And then I want to show you a very quick thing, which is the little bit of chaos engineering. What you can do, you can use a certain complex scenario. So for example, I can do static network and create a topology of my classes. So we're going to do network equals network new network. And I'm going to put Redis on network with network. And I'm going to create this static container called ToxiProxy, which is a nice container that by Shopify, new ToxiProxy container. And this is Shopify ToxiProxy. Wait, this one. ToxiProxy, say 210, right? What this container is doing, so I can put it on the same network as my Redis with network. And then what I can do all kinds of cool things here. So I'm going to say, start this ToxiProxy, and then I'm going to say, ToxiProxy, give me the proxy for Redis to the port 6379, and this will be my Redis now. And then here I will say of Redis, I will say my proxy get container IP, and then proxy get the port. And after that, what I can do, I can say proxy, please introduce the toxics. So latency, and then we're going to say that all downstream interactions are going to now to be 2 seconds long. So now my tests, right? So my tests run very, very fast. And now if I run my test again, I think it will be much, much slower. Because I introduced just a little bit of a chaos engineering practices into this. And you can do complex things, right? You can cut the network completely. You can introduce jitters. You can do various things. And the cool thing, you can see how slowly it runs. It runs very slowly now, because every time when you go to Redis, it takes like 2 seconds. You can verify that the application works while the certain databases are not available. And also, if you are sort of on a platform team, where you want your application developer, other developers to kind of use that, what you can do, you can create your own abstractions, right? It doesn't have to be a module that does only, like, starts one container. You can have the module that starts both Redis and ToxiProxy together, and it sort of mimics to the outside, it looks like Redis. But inside, it runs also with ToxiProxy, so we can verify that your application, like all the tests that you run, will be checking the resilience of your application as well. So I could show you more demos, but like it's a little bit late, right? So what I wanted to finish was, a little bit, like you can find the demos and you can find the links, and it's all available online. And well, you can of course find that. But what I wanted to say is, I wanted you to kind of sort of tap into your memory and into your experiences and think about the projects that you worked on. Specifically, the legacy projects, right? If you're blessed with no experience with legacy projects, ask your neighbors. It can be uncomfortable, like being like, oh, what's the worst you've seen? But it's a conference. Networking is part of the game. It's a good topic. So legacy projects, and like all our experiences and stories will be different. There might be like awkward deployment scenarios, or like technologies that were created and used just because we didn't know better, or like software that was delivered without realistic deadlines, and that's why the code is hard to change and everything. But one thing I'm pretty sure, like I can almost guarantee you that one thing that you will never find in the legacy projects that are really hard to work on is good tests. You will never find a project with good test suite that is sort of hard to maintain. So when you go back to your projects after this conference, right, and you will get back to your like backlogs of Jira issues and your deadlines and your project managers who don't maybe understand software engineering that well, right? Do yourself a favor, yourself and your team, and yourself like 6 months in the future, figure out how to run good test suite, right? And then you will thank yourself when you, like, in the future, you're looking back and like, oh, this is great. Because this is one reliable way to create great software, is to ensure that it can be changed very easily, embracing the change. And then well, not just like any random change, like changing the software without actually breaking things. And then you can move fast, and then it will those skills will stick to you throughout your career. You can change your languages, you can change your frameworks, you can change your domain models, but knowing that the good tests will make you write good software is essential, right? So embrace change. Make sure that you can change your software easily, that the tests are simple to create, consistent to run by everyone on the team, and sort of high level enough that they don't break at like every small refactoring. And then you're gonna go and build great things, because there will be nothing that can stop you. That's sort of all that I have. Thank you very much for coming.